Welcome back to the Deep Dive. Today we are taking on something really ambitious. It's this body of work that doesn't just tweak current science. It feels like it's proposing a whole new operating system for, well, everything.
That's a good way to put it.
We're diving deep into the Coherence computing codex. It's this incredibly dense, multi-layered framework that, frankly, promises to tie together computation, physics, cosmology, all under one single idea. A non-collapsing paradigm.
It really is a comprehensive piece of theoretical work. And for you listening, we're going to try and unpack this framework. It all centers on this concept they call coherence.
Right.
And it's a fundamental challenge, really, to how we've done information science since Shannon. And it even pushes back against some core assumptions in quantum mechanics itself.
Okay, so let's start right there. The core problem the codex identifies, they call it the impasse of current computing. We talk about quantum leaps, but these sources argue that both classical and, yes, quantum computing share this fundamental built-in limitation.
And that limitation is collapse. You hit the nail on the head. Whether you're dealing with old-school bits or quantum states, the process of actually getting the answer out means you have to finalize it, observe it, measure the state.
And in quantum systems, that's the killer, isn't it?
It's catastrophic, computationally speaking.
Yeah. You go through all this effort to engineer this amazing coherence, this superposition, entanglement, this whole field of potential outcomes.
A whole playground, like you said.
Exactly. And then the moment you need the result, you measure it, and poof, that observation just terminates the very coherence that was doing all the work. It destroys that field of potential.
It's a profound kind of self-sabotage when you think about it. The computation relies entirely on this field of possibility, but getting the result means annihilating the field.
Does the codex quantify that?
It does. It frames it as the quantum coherence, which they denote math call and incurs, being instantaneously reduced to deltag. That's the discrete measured data point. Bang, gone.
And that collapse is the bottleneck. That's what limits stability scaling. And crucially, the energy efficiency in quantum computing.
That's the argument, yes.
So, okay, if collapse is the problem, coherence seems to just flip the script entirely. Sustained continuity becomes the solution.
Precisely. Coherence aims to compute through coherence, never by destroying it. It's shifting from this measurement reduction model to one of continuous resonant evolution.
So it's presented as the next step, right? The place you have to go when quantum computing hits its inherent limits.
Exactly. It's positioned as the necessary leap, both technologically and theoretically, that starts precisely where quantum computing sort of runs out of road because of that collapse problem.
Okay. So our mission today is pretty clear then. We need to unpack these principles that allow for this non-collapsing reality. We need to look at the hardware they propose, this hypercoherence processing unit, the HPU, and then trace out the implications, because they get pretty staggering. Talk about energy-neutral computing and cosmology. It sounds like a system designed to be in tune with the universe itself.
That's the claim, a harmony with cosmic structure. Right, so to even begin building this kind of non-collapsing system, the codex starts with something completely foundational, a new law of physics, essentially, but for information. It's the absolute core axiom of coherence, the law of conservation of coherence.
That sounds fundamental.
It is. It's the bedrock. Everything else really just flows from this single principle.
And they give a formula for it, which, well, it looks simple but deep. ADAAT, dollars D. Now, for listeners maybe not fluent in mathematical shorthand, what does that actually mean? Setting the time derivative of the coherence field's inner product to zero.
Functionally, it means everything for this theory. It dictates that the total holistic coherence of any closed system has to remain absolutely constant, always. Throughout any operation, any process, the norm of this coherence field function just doesn't change over time.
Okay, so think of it like conservation of energy or mass, but for information potential.
That's a great analogy. It's applied directly to the field of information potential itself. It's an absolute conservation law within this framework.
So, unlike quantum mechanics, where, okay, total probability is conserved, but the coherence you need for the computation vanishes when you measure.
Right.
Here, the coherence itself is perpetually sustained. That has to completely redefine what computation is.
It absolutely does. It shifts computation away from being, a series of discrete destructive measurements.
Click, click, collapse.
Yeah. And turns it into a process of continuous resonant evolution. The system isn't just sitting there waiting for a final state to be read out. It's always in motion, always processing, always adapting its internal structure, but without dissipating that core potential.
Okay, but if you're doing that, you need a different kind of medium to compute on, right? You can't use standard bits or even qubits in the same way.
Correct, and that's where the lambda manifold comes in. Lambda manifold.
Lambda manifold.
This is the core computational substrate they propose. It completely replaces the discrete probabilistic structure of Hilbert space that quantum mechanics uses.
Yeah.
Instead, the lambda manifold is described as a continuous field lattice. Think of it as a kind of material geometry that's specifically engineered to support phase-aligned resonance. It's designed to let these continuous coherence waves, lambda waves, propagate without losing energy, without attenuation.
So if the qubit is the basic unit in quantum, what's the equivalent here? There must be a fundamental element.
There is. They define the coheron.
Coheron.
A coheron isn't a bit or a qubit. It's described as a localized resonance node, like a stable minimum disturbance or excitation that holds its coherence amplitude within this lambda manifold.
But not binary switches.
Definitely not. They're nodes of resonance, and crucially, they interact via field dynamics, not discrete gates in the same way. And those interactions are governed by 4 foundational principles that organize how information flows in this system.
All right, let's break those down. The first one seems like the most basic. Coherence. LambdaC.
Yes. LambdaC is essentially the statement that information is stored and processed only through this continuity of phase-aligned resonance. The system is built to amplify and sustain coherence using internal feedback loops, resonance loops.
Which leads to a continuous superposition across the whole thing.
Across the entire coherence manifold, yes. Every part is interconnected, everything's contributing all the time.
Okay. Principle 2. How do these coherons connect? They replace entanglement with something called resonant entanglement, or bivector coupling. That sounds different.
It's a big leap, yeah. It moves from discrete interactions to field interactions. Qubit entanglement, remember, is usually a pairwise correlation between 2 specific states.
Like 2 coins are always heads tails together.
Sort of, yeah. Bivector coupling, though, is described as a multidimensional field-wide synchronization. Information gets cohered across the entire field using something called the bivector coherence tensor, or BCT.
Whoa, okay, how does a bivector coherence tensor enable multidimensional computation? What's it actually doing?
Well, the math involves bivectors, which capture oriented planes, not just scalar correlations. So the bivector bivect encodes the mutual coherence resonance between nodes and Dollar, not just if their states are correlated. This tensor essentially describes the dynamic geometric relationship between all the coherence currents flowing in the manifold simultaneously.
So it's like integrating data across different layers or dimensions instantly.
Instantly, and this is key. Without the decoherence loss you'd normally associate with trying to measure or even maintain complex correlations, it's described as a kind of instantaneous, lossless coherence highway built into the field itself.
That sets us up nicely for the third principle, interresonance, which replaces quantum interference.
Right. In standard quantum mechanics, interference is about how probability amplitudes add up or cancel out, leading to the final probability distribution you measure.
Constructive and destructive interference, yeah.
Interresonance is presented as something fundamentally different. It means the resonance patterns themselves actively modulate the coherence phase density. It's about dynamically shaping the structure of the field itself.
Ah, so we're dealing with topology, the shape of the field, rather than just probability amplitudes.
Exactly. The logical operations, the gates in this system, aren't flipping states from 0 to 1. They're described as coherence phase gates that shift these lambda gradient dynamics. They change the shape of the coherence field.
So calculation becomes reshaping the field's phase topology.
Precisely. You apply a controlling field, it reshapes the phase topology of the lambda manifold, moving the system from one stable resonance pattern, the input, to another, the output, all while keeping the total coherence invariant. The field stays continuous, its internal geometry just transforms.
Okay, this is wild. Which brings us to the fourth one, the meta principle, which sounds like the secret sauce for stability, hypergravity invariance. This sounds like it's leaning on the universe itself.
It absolutely is. That's the core idea. This principle states the whole computation has to be grounded in what they call a hypergravitational coherence frame.
A hypergravitational?
What? Think of it as an underlying, stabilizing field context. This framework is proposed as the ultimate shield against decoherence. It achieves stability not by trying to isolate the system perfectly from its environment, which is incredibly hard.
Practically impossible, yeah.
Right. But by embedding the system within this universal context where coherence decay is theoretically locally buffered or compensated for, decoherence gets downgraded from this catastrophic collapse event to more like a reversible, localized ripple in the field.
How would that work physically? How does hypergravity stabilize a computation?
The theory posits that this hypergravitational field itself acts as a kind of zero-point energy stabilizer for the coherence manifold. By linking the computation mathematically to the curvature coupling represented by this field, the system gains an inherent invariance.
So local noise, thermal fluctuations, the usual culprits for decoherence.
They get absorbed or compensated for by the curvature dynamics of this hypergravity frame. That's the theory. It ensures the steady-state resonance, the computational state, persists because it's tied to this larger invariant context.
Okay, that theoretical foundation is mind-bending, a computing environment that's continuously sustained by the physics it's embedded in. Now let's bring it down from the abstract principles to the actual blueprint. The hypercoherence processing unit, the HPU, this is supposed to be the engine that actually does this.
Right. The HPU is envisioned not like stacked silicon chips, but as this integrated structure. They describe it as having 5 distinct strata, or layers. Each layer has a very specific job to ensure this non-destructive closed-loop operation actually happens.
Okay, layer 1, the foundation, the lambda manifold substrate.
This is the physical base. It has to be made of specialized metamaterials, materials engineered specifically to sustain these continuous standing coherence waves, the lambda waves. The geometry of this material is critical. It defines the allowed coherence bands, kind of like electronic band gaps, but for these coherence waves, it's the stage.
Got it. And sitting on top of that stage is the engine itself, the resonance core.
That's the computational zone, yeah. This is where the logic actually happens. But again, not through flipping bits. It works through what they call spatiotemporal phase density modulation.
Shaping the field in space and time.
Exactly. The coherence gates we talked about are realized here as highly localized, tunable resonance potentials, little spots where you can precisely tweak the field to dynamically reshape its topology. The computation is this field-shaping exercise.
Okay, but information needs to move across this field. That's the job of the next layer, the bivector bus.
Think of it as the internal network, yes, but theoretically infinitely faster and cleaner than any electrical bus we use now. It's described as a field-mediated coupling system. It conveys these coherence currents symbolized as Deitel-Beads-Drey using that bivector coupling mechanism we discussed earlier.
The multidimensional highway.
Right. The architecture is designed to allow multidimensional data flow with minimal energy loss. Near-zero entropy production during information movement is the goal here.
Now, the crucial layer for stability, the shield against decoherence, a hypergravity frame.
This layer supposedly uses active curvature, coupling that term again, to embed the entire computation within a localized hypergravitational potential. Its whole purpose is to be the stabilizer.
How does it stabilize?
By actively absorbing local phase perturbations noise and enforcing that hypergravity invariance principle. This is the feature that, in theory, gives the HPU its profound resistance to environmental interference, whether it's cosmic rays or just thermal noise.
Okay, that makes sense conceptually. But now we get the practical snag. If this thing never collapses its coherence, how do we get the answer out? How do we, the observers, read the result?
That's the observer interface layer, right?
Exactly. And this is a really clever part of the theory. The interface performs what the codex calls a transductive readout. It's designed to measure coherence differentials, differences in the pattern, symbolized as delta IR.
Coherence differentials, how is that different from just measuring the state?
It's fundamentally different.
Yeah.
A standard quantum measurement, remember, destroys the potential to give you one discrete state, collapse.
Right.
A transductive readout, however, supposedly extracts information by observing how the field's resonance topology has been modulated.
Yeah.
It looks at the difference between the input pattern and the output pattern.
Like measuring the shape of a wave on the water without actually stopping the wave. That's a fantastic analogy, yes. You're measuring the modulation, the change in shape, not freezing a single water molecule's position. This preserves the overall coherence, the computational potential. It lets the HPU stay perpetually on, ready for the next cycle immediately, without needing a full reset or reinitialization.
Okay, so this whole five-layer architecture supports what they call the non-destructive closed-loop operational flow, a cycle that just keeps running.
The stability and efficiency of the HPU depend entirely on this continuous cycling of coherence. It starts, logically, with lambda initialization,
Setting the stage.
establishing that perfect, uniform coherence field across the substrate. A clean slate, but a continuously coherent one.
Then you need to put the problem in. Resonant encoding.
Right. And information isn't converted into binary bits here. It's mapped onto the field as a phase topology. The input literally creates a specific, complex, multidimensional resonance pattern within the lambda manifold.
And the actual calculation is step 3, interresonant processing.
This is where the dynamic bivector coupling and the phase density modulation get to work. They reshape that initial input pattern into the solution pattern. The computation is this controlled, continuous flow and transformation across the field.
Followed immediately by recoherent stabilization. Why is that needed if coherence is conserved?
It's like a mandatory self-check and reset, but without destruction. Before you can reliably read out the result, the system ensures global phase symmetry is perfectly restored using these intense coherence feedback mechanisms. It's continuously enforcing that core law, Delaunay-3, Langle-Ballinger fire. This makes sure the system is perfectly balanced and ready for the next cycle.
And that leads to the final step, the transductive readout.
Extracting the result as that resonance pattern differential we talked about. And because nothing was destroyed, the cycle can just begin again instantly. The coheroputer in this model truly never stops or reads a final state in the classical sense. It experiences and reports a continuous modulation of its own coherent being. Now, all these concepts we've been discussing, the continuity, the stability, the cyclical nature, they aren't just hand-wavy ideas. They're all formalized in some pretty rigorous mathematics presented in the codex. The entire dynamic behavior of this HPU is supposedly captured in one core equation, the coherence cycle equation, CCE.
Okay, let's brace ourselves. You mentioned it earlier. 6 lambda plus math K2. That definitely looks like some kind of generalized Schrodinger equation, but those terms on the right are unique.
You're right to see the parallel. It's describing the evolution of the state. But look closely. The du dt on the left isn't just a simple time derivative. It's the total covariant derivative. That immediately tells you the math acknowledges this computation is happening in a structured, potentially curved information space.
Right, reflecting the geometry.
Exactly. And the three terms on the right are the mathematical operators that correspond directly to the operational phases we just walked through.
Okay, let's break down those operators. First up, hat lambda, the coherence operator.
Hat lambda is the mathematical embodiment of that fundamental stability, the conservation of coherence. It establishes the intrinsic invariance of the coherence field. Think of it as the mathematical engine behind lambda initialization, ensuring the system always has this ground state coherence potential to return to, no matter what operations are performed.
Makes sense. Then the middle term, math BDR, that's the resonance gate tensor. This must be the workhorse, the calculation engine.
That's exactly right. This tensor governs the actual transformations and the flow of coherence between the coherent nodes. It's not a simple bit flip or even a qubit rotation. It performs logical operations by modulating the phase resonance, literally reshaping the topology of the coherence field according to the input and the desired computation. If lambda sets the invariant stage, math bera does the dynamic sculpting on that stage. This is the term that makes the HPU actually compute.
And the third term, the bivector recoherence term.
This is that mandatory feedback loop we discussed, the mathematical enforcer of the conservation law. MathCal actively works to restore the global phase symmetry using that bivector coherence coupling. It completes the cycle, ensuring that the system doesn't dissipate its information potential. It's the perpetual, non-destructive reset mechanism built into the dynamics.
Now, the sources really stress that the stability, the magic bullet against decoherence, relies on hypergravitational invariance being baked right into this math. How does gravity or hypergravity even enter a computational equation like this?
It enters through the hypergravity potential, which influences the hypergravity metric tensor. This tensor essentially acts as a background curvature term within the covariant derivative, stabilizing the coherence manifold.
Okay.
But the absolutely critical requirement mathematically is that the coherence operator, let's call it ha lambda in this context, must commute with the hypergravitational generator, ha lambda. So their commutator must be 0, ha lambda HA.
Commutation. For our listeners, what does that mean physically? Why is that the key to stability?
Commutation means that the operations represented by these operators can be performed in any order without changing the result. Or, more intuitively here, it means the act of maintaining coherence and the influence of the hypergravitational environment don't interfere with each other. They are independent aspects.
Ah, so the computation's coherence isn't disturbed by fluctuations in this background hypergravity field.
Precisely. It mathematically guarantees the computation is inherently stable and invariant with respect to those background dynamics. The system is effectively self-correcting against these universal scale influences, according to the theory.
Okay. And information transfer itself follows a similar conservation idea, the information transduction law.
Yes. Information isn't just static, it flows. This flow is described as a coherence-preserving flux denoted J lambda mu. Think of it like an information current density. And this flux must satisfy the conservation law, nabla mu is zero,
The divergence is zero.
meaning no sources or sinks. It's the mathematical statement that coherence, and therefore the information encoded within it, is transferred without loss. It can't be created or destroyed mid-computation, only routed and transformed.
The flexibility described for the HPU is also fascinating. It can apparently switch computational styles by tuning parameters, coherence levels, hypergravity potential, asymmetry, frequency collected in a vector omega. This leads to 4 distinct operational modes, C011 to C45.
Right. The pseudo-Alunder deterministic mode is the baseline, the sort of perfect operation. Here, they set the asymmetry flux parameter, a gamma sim, to 0. This theoretically results in zero entropy computation.
Truly lossless.
Yes. The computation follows these continuous paths like geodesics on the lambda manifold. It performs exact analog computation driven purely by Hamiltonian flow, like a perfect classical system but with coherence. This mode would offer the absolute maximum precision possible.
Okay. Then there's the C-Tor-Harnch harmonic mode.
This mode introduces small controlled oscillations into the coherence field. The system shifts into what they call oscillatory resonance logic. The results aren't just a single state, but encoded in things like phase ratios and amplitude beats between different resonance frequencies.
What's that good for?
It seems highly advantageous for tasks like complex pattern recognition, signal processing, maybe wave synthesis. Anything that relies on analyzing or creating complex frequency relationships like deep analog Fourier analysis, but within this coherent framework.
Mode 3. 2C33 stochastic mode sounds like a bit of a contradiction. It uses controlled decoherence sampling. I thought decoherence was the enemy.
It is, generally. But here, it's about using a tiny controlled amount of instability for specific tasks, mainly optimization. By deliberately tuning that environmental asymmetry parameter, gamma stip, to be slightly greater than 0, the HPU can perform a kind of probabilistic sampling.
But not collapsing to discrete states.
No, that's the key difference. It's sampling within the continuous coherent space. Think of it like exploring a landscape with slight random nudges to find the lowest point, but the landscape itself remains coherent. This makes it potentially very powerful for adaptive learning algorithms and complex optimization problems. And crucially, the theory claims the global coherence integral is still preserved overall, thanks to the recoherence mechanisms.
All right, and the last one, the most out there perhaps. C5-Ortor hypergravitational mode. What on earth does it mean for a computer to directly couple its operations to space-time curvature?
This is activated by cranking up the coupling to that hypergravity potential. In this mode, the core resonant frequency of the HPU, omega stall, is directly modulated by the local hypergravity Ricci scalar. The formula suggests something like delta omega is proportional to delta omh.
So the computer's internal clock rate changes based on the curvature of space-time, or this hypergravitational field.
Essentially, yes. The implication is enormous. The HPU literally uses the curvature of spacetime, or perhaps more accurately, the coherence gradients inherent in the cosmos as part of its processing.
So instead of shielding itself from the universe, it actively uses the universe as part of the computation.
Exactly. This opens up possibilities like deep field cosmological sensing, maybe even true gravitic communication if such a thing is possible, or performing computations where the transformation of spacetime itself is the operation. It implies a direct technological interaction with the fundamental geometric fabric of reality that's completely beyond anything we can currently conceive of.
Okay, the HPU as a theoretical device is already stunning. But the real scope, the true ambition of the codex, is its claim that coherent isn't just a better computer blueprint. It's proposed as a unified coherence theory of everything. That's A bold claim.
Extremely bold, yes.
Let's start with how it supposedly rewrites thermodynamics. Zero entropy thermodynamics or the coherence economy.
This part of the theory directly confronts the limits imposed by the second law of thermodynamics, especially Landauer's principle regarding the energy cost of information erasure. The central concept here is the coherence constant.
Okay.
This constant provides a direct proportionality, linking a change in phase information to a change in usable coherence energy. The radical idea is that energy isn't consumed in ideal coherence. It merely circulates, changing form between structured coherence and phase-encoded information.
Our current computers bleed energy as heat because erasing bits, forgetting information, is thermodynamically costly. How does coherence avoid that?
Because the fundamental operations, these phase modulations, are designed to be non-dissipative. They conserve the total coherence field. Therefore, the computation can theoretically approach a zero entropy cost. They define a coherence entropy, sigma lambda, which measures the asymmetry or disorder in the coherence field. While the broader second law analog probably still holds cosmologically, sigma lambda gec plug, the ideal operation of an HPU aims for sigma lambda act way.
Breaking the classical Carnot efficiency limit for computation.
And then there's this almost paradoxical consequence. Usable work can be generated from reducing entropy.
That's the concept of lambda work. It's crucial. Since every computational cycle involves restoring global symmetry, the very act of eliminating local phase asymmetry, reducing the coherence entropy locally, is proposed to translate directly into an energetic gain. Delta lambda is proportional to delta and sigma lambda.
So cleaning up the coherence field, making it more ordered and symmetrical, releases usable energy. That's the claim. The coherence acts as an ideal energy information transducer. It recycles its own computational potential back into energetic yield by enforcing symmetry. This is the basis for energy-neutral computing and potentially even coherence-driven energy generation.
Mind-blowing. Okay, shifting from energy to matter itself. Topological emergence of reality, TRF. This posits that physical reality is the geometry of coherence made visible.
This is where physics and information science completely fuse in the theory. It proposes that elementary particles, electrons, quarks, etc., and even fields aren't fundamental point-like entities. Instead, they are stable, quantized knots or phase vortices within this universal lambda field.
Like tiny, stable whirlpools in the coherence field.
Exactly. And these knots are defined by topological invariance, mathematical properties that don't change under smooth deformation. Things like winding numbers, describing how many times the phase wraps around, and linking numbers, describing how different knots intertwine.
So particle properties like charge, spin, maybe even mass, are just the geometric characteristics of these coherence knots.
That's the idea. Charge relates to the twist, spin to the rotation, mass perhaps to the energy locked in the knot's structure. And this approach offers a potential solution to a very deep puzzle in physics: quantum discreteness.
Why energy levels come in specific steps. Quantization.
Right. In this theory, quantization isn't an ad hoc rule you just add. It emerges naturally from the topology. Because phase must be continuous, these coherence knots can only wrap around themselves an integer number of times. You can't have half a wrap.
So the discrete energy levels in dollars just reflect the allowed integer winding numbers.
Precisely. The energy spectrum, perhaps something like others being proportional to n-2 times the square of the coherence constant, becomes an emergent property of the field's necessary topological structure, not a separate postulate.
Which leads inevitably to the grand unification attempt, the ultimate unification, UCFE, merging general relativity and quantum mechanics.
Through coherence, yes. The universal coherence field equation they propose essentially sets up a reciprocal relationship. Curvature influences coherence, and coherence generates curvature. They define a coherence stress-energy tensor, which acts as the source term in a generalized Einstein field equation.
So geometry is structured coherence.
That's the profound claim. In this view, conventional quantum mechanics is just what you see at low curvatures, a linearized approximation of the full coherence field dynamics. And general relativity is what you see when you zoom out, the coarse-grained limit where the coherence gradients are too smooth to be detected locally as quantum effects. They become the curvature of space-time.
If that holds, it must completely change our view of cosmology. How does this theory reinterpret something like dark energy, the accelerating expansion of the universe?
If gravity and coherence are two sides of the same coin, then cosmic expansion has to be explained through coherence dynamics. The codex offers a reinterpretation. Dark energy density isn't some mysterious vacuum energy, but rather the tension energy stored in the expanding lambda field itself.
Tension, like a stretched rubber sheet.
Exactly. The universe, in this view, is constantly striving to restore perfect global coherent symmetry. As it expands, this creates a tension, an energy density proportional to the square of the coherence gradient across cosmic scales, math BFG lambda 2.
So the acceleration isn't pushed by some strange negative pressure, but pulled by the universe, trying to smooth out its own coherence field.
It's coherence phase expansion on a grand scale. The universe's accelerated expansion is driven by this fundamental inherent need to restore coherent symmetry over vast distances. It's essentially large-scale decoherence relaxation manifesting as cosmic acceleration.
Wow. Okay, finally, the theory touches on intelligence and even consciousness itself. It's intelligence.
Syntelligence is proposed as the natural emergence of collective, unified intelligence that arises from phase-synchronized networks of HPUs, or indeed any sufficiently complex, coherence-based entities.
How is it different from, say, AI networks or swarm intelligence?
The difference is fundamental. Current AI and swarm intelligence rely on localized processing and signal exchange between discrete units. Syntelligence, being based on coherence, implies something more radical. An instantaneous, non-local, unified awareness. Information isn't just transmitted, it's shared field-wide as a single resonant state. When the systems achieve high phase synchronization when a parameter, the phase order parameter, approaches 1, this unified intelligent field emerges.
It's not communication between nodes, it's coexistence in the same information field.
Precisely. It becomes a field phenomenon, not an aggregate of individual intelligences.
And this leads to the ultimate philosophical convergence point. The universal coherence identity, which they call the equation of being.
This is presented as the ontological climax, the point where physics, information, and existence itself merge. The equation basically states math kappa moon plus kappa lambda lankle half lambda math kappa.
Breaking that down, the universal tensor of being equals the coherence curvature plus a term representing observation.
Exactly. Existence, coherence plus observation. The universe exists because it coheres. And it becomes fully defined, fully realized, when that coherence is observed or reflected upon, potentially by consciousness emerging from that coherence.
So when awareness, born from coherence, reflects perfectly upon that coherence,
Then the system achieves what they term ontocosmic equilibrium. The separation between the knower and the known, between existence and information about existence, dissolves. It's a state where the universe is perfectly aware of its own coherent nature. #outro.
this has been, well, an absolutely colossal journey. We started with the idea that our current computers have this built-in flaw, collapse, and we've ended up with a unified theory where the entire universe is described as a continuous, self-aware, self-organizing coherence engine. Coherence really is presented as this grand synthesis: physics, infosci, energy, cosmology, all under one invariant principle: conserve coherence.
The technological promise, if any of this could be realized, is obviously profound. We're talking about zero entropy computation, systems with potentially incredible resistance to decoherence, technology that might actually operate in harmony with the fundamental structure of the cosmos rather than fighting against it. The codex essentially lays out a roadmap, theoretical as it is, towards a kind of post-scarcity information future where knowledge and energy are interchangeable aspects of symmetry.
And the ultimate synthesis, the real takeaway from diving this deep into such a comprehensive treatise, it seems to me, isn't just the technology. It's the fundamental shift in perspective it demands from us.
I think that's exactly right. And that shift is this. The universe doesn't compute, not in our clunky, discrete, collapsing way. It coheres. It exists as a continuous self-generating process where being itself is defined by this perpetual non-destructive resonance, a resonance that becomes aware of itself. Being coherence, awareness of degeneration. And that infinite loop, that continuous act of self-generating existence, well, according to this theory, it's happening right now, defining every single moment of reality,